there are some important things that you need to understand about series. So let's just look at this example, 1 over n. If you try and sum up all the terms from the first all the way to infinity, from the first all the way to infinity, if you sum up everything, for some reason, this thing here, the whole sum will just diverge. Um, at the moment, you don't understand why it is that when you sum up everything for 1 over n, it diverges. At the moment, you don't understand why. I'm just asking you to accept it for the time being. We will try and understand why in the future, but for the time being, just accept it. And but then when you look at 1 over n squared, if you sum up everything from the first term all the way to infinity, from the first term all the way to infinity, for 1 over n squared, for some reason, this thing here will converge. For some reason, this thing here will diverge. Just note that when you look at each individual term, this thing here is getting closer and closer to zero. This thing here is also getting closer and closer to zero. Each individual term, 1 over 16 is getting closer and closer to zero. This is getting closer and closer to zero. The point here is that they're both heading towards zero. Each individual term is heading towards zero. But then for some reason, this the sum of the whole lot will diverge. For some reason, this thing here converge. Just for the time being, just know that each individual term is getting smaller and smaller and smaller. It's heading towards zero. But this thing here will diverge. This thing here will converge for some reason. So let's just look at this made up sequence. Sorry, let's look at this made up series. So here you've got 7, and then it's getting smaller and smaller here. For this sequence here, sorry, this series here will converge. But then if you look at this made up series, 7, and then here you've got a small number plus exactly the small number. This, if you sum up everything from 1 to infinity, if you sum up everything here, this will head towards infinity. It will diverge. It will just get bigger and bigger and bigger, because here you're adding. Just note that this is heading towards zero, heading towards zero, heading towards zero. This is staying the same, staying the same, staying the same. Even though it's a small amount, you're adding a small amount each time, because you're summing up everything. You see, this series will diverge because you're adding more and more and more each time. So eventually, this thing is just going to head towards infinity. Even though it's a small amount, even though you're adding a small amount, but you're adding a small amount each time. You're adding another amount, you're adding another amount, you're adding another amount. Each time you're adding a small amount. So, of course, eventually this thing here is just going to get bigger and bigger and bigger, even though you're adding a small amount, but you're still adding something each time. Here, you're adding something each time, but the amount is getting smaller and smaller and smaller. The point I'm trying to make here is that if the whole series converge, then the sequence, each individual term must head towards zero. Here, this thing here is not heading towards zero. This thing here is going to diverge. So in order for a series to converge, the sequence itself, each individual term, must head towards zero. You see, this is heading towards zero. So if you have a series that converges, then it would imply that each individual term must head towards zero. Now, going the other way is not true. Because if you look at this here, hang on. If you look at this example here, each individual term here is heading towards zero, but then it doesn't imply that the series itself is going to converge. So going the other way is not true. But then going from left to right. So if you have a sequence that converges, then it will imply that each individual term must head towards zero. But then going the other way is not true, because here each individual term, you can see, is getting closer and closer to zero. But that doesn't go the other way. It doesn't imply that this is going to converge. So something important that you should bear in mind is that, if a series is going to converge, then the sequence must head towards zero. But going the other way is not true. Okay, so bear that in mind, because most of the time we want to understand what's going on here. We don't understand this thing here. We want to know about the series, because it gets complicated. We want to understand about the series. But what we do is we look at each individual term. We look at the sequence. If the sequence diverges, then this will not converge. So we can look at the sequence. Now, if it converges to 0, it doesn't tell us much. It doesn't tell us much. But if it diverges, then we know that the whole series will diverge, because in order for this to converge, it must mean that this thing here is each individual, that this sequence is heading towards 0. But then if the sequence diverge, then this thing here must also diverge. So most of the time we don't understand about a series. So we would look at each individual term. We would look at the sequence. If the sequence heads towards 0, then we don't know much about the series. But if the sequence diverges, then the series must diverge. And also something to bear in mind: if you look at this here, if you look at this sequence an here is heading towards a limit, but the limit is not heading towards 0. Let's say the limit is 3. So here, because the sequence is not heading towards 0, then we can say that this thing here is going to diverge. Because if you think about it, each time you're adding 3 to the whole sum, and then you're adding another 3, and then you're adding another 3, and then you keep on adding a small amount. So of course this is going to diverge. So if you have a sequence that's heading towards a limit other than 0, then you know the series itself will diverge. And then if you look at this here, if it oscillates, it also diverges. It does the whole series doesn't converge if it oscillates. Okay, so just bear that in mind. What's important is this here. So we would try and understand this thing here, but then we would look at this to try and understand this. Okay.